Okay, so in this lesson, we talked about measures of center, measures of variability, and there were two measures of center, mean and median, and there were three measures of variability, range, standard deviation, and interquartile range, right? So the last thing I want to talk about is when we compare those measures. Because some are better than others, depending on the situation. This was our original data for the salaries. Okay? This we've been using since the beginning of the lesson. If you go back to the first page, we saw that the median was $50,100. Sorry, the mean. We saw that the median was $34,500. That's a pretty big difference between the two. Okay, when both of them are supposed to measure the center. Why is there such a difference? Look at these numbers, and why do you think there might be such a difference between the two? Why is the mean so much bigger than the median? It's the 185. Okay, because remember, mean is the average. So if there's an extremely high value, it'll pull the mean up. If there's an extremely low value, it'll pull the mean down. But it won't do the same, it won't have the same effect on the median. Okay? I mean, if this wasn't here, the median would still be around 34,000. The middle number. Okay, but the mean would go way down if this wasn't here. So what we say is the median is resistant to outliers. So it's not seriously affected by outliers or a strong skew. Whereas the mean is not resistant. If there are extremely high values or extremely low values in a distribution or a set of data, okay, that's going to impact the mean much more than it is the median. Remember how we calculated the median, or sorry, remember how we calculated the interquartile range? We used the median to help us. So median and interquartile range are connected. So if the median is resistant, so is this one. Mean and standard deviation are connected. So if the mean is not resistant, neither is the range and standard deviation. So we've kind of just talked about what I'm going to write down here. So for the mean in this, for these salaries that we've been working with in this lesson, that very high salary drags up the mean because its high value is given a lot of weight. Where it's not given as much weight, and actually we don't really use weight. The median we use position, so the position matters more than the weight. And if the position matters more than the weight, the outlier won't have as big as an impact, so it's not given a large weight. So you kind of have to think of it like, and I'll talk about this a little bit later, Let's take a distribution of data and let's say it's roughly symmetrical. In this case, the center of the data, the mean or the median, would be the same. So that's an ideal world. If we had a peak number and all the same numbers below and all the same numbers above, and everything was weighted properly, the mean and median would be identical. As soon as it starts to skew, you have to think of the median that is cutting this distribution into two equal areas. So the median would be somewhere around here. It gets pulled a little bit to the left, but this area would be about the same space as this area. That's why when we talk about median, we talk about position. The mean would be, think of this as a block. Where would you put the mean below to balance it? You would put it a little further over here to balance it. To balance the weight, because this side is being given more weight because it's got some outliers. Okay. That's how you can kind of look at mean and median. I mean, you don't really have to look at it that way. All you have to really remember is that if you've got low values, the mean is going to be lower than the median. If you've got high values, high outliers, the mean is going to be higher than the median. If you don't have low or high values and it's perfectly distributed, then the mean will be the same as the median. Okay? And then the other thing, the median and the IQR are resistant to outliers. The mean and the standard deviation in the range are not. So that takes care of